Hello everyone, in this video let's discuss about the transistor as a switch in electrical engineering. So if you see, the transistor can be used as switch and it can also be used as the amplifier and for many other. So you can tell the transistor as the basic building blocks of electrical circuits. In 90 to 95% of the electrical circuits are designed using the transistor. So here we will discuss how the transistor can be used as a switch, and I will give the brief and I will give the short introduction about how it can be used as the amplifier. So if you see here, let me consider a waveform, whether it may be of the voltage or it may be of the current input. So it will be having positive half cycle and negative half cycle. When you introduce an amplifier which will be consisting the transistor, in that amplifier we will be having the transistor. So what it will do is it will amplify the amplitude, that is it will increase the height of the waves. So the distance from here to the top of the waveform will be called as the amplitude. So from here to here, the distance will be called as the amplitude. This amplifier will increase its amplitude, that is it will increase the height. So in that amplifier we will be using the transistor. Like that only, using this transistor, how can we use it as a switch? Let's discuss now. Here, to discuss about transistor as switch, I am using the common emitter configuration. You can use common collector also, common base also. So if you see here, since it is common emitter configuration, the emitter is grounded. So its voltage will be equal to 0. So it is in between base and collector, emitter is grounded. Common emitter, which is common between the base and the collector. So you can tell that the voltage between base and emitter will be called as VBE, and the voltage between base and collector will be called as VBC, and there will be no current flow in the emitter. The current flowing through the base will be called as the IB, and the current flowing through the collector will be called as IC, and there will be no flow of current through the emitter because the voltage will be equal to 0 since emitter is grounded. Now if we see the inputs and the outputs, So first, what are my input voltages and output voltages? So my input voltage is, if you see, Vin is my input voltage which is coming through the base. So Vin is my input voltage, and what is my output voltage? My output voltage is VCE. Next, what is my input current? So input voltage is coming through the base, so you can conclude that the current from the base will be the input current, and here at the emitter we can't have any current, so only current left is IC, that is collector current. You can tell the collector current as the output current. Now to discuss about the operation, how the transistor work as switch, we will be using the bipolar junction transistor. In that transistor only, the advanced one is bipolar junction transistor. Bipolar means it will use the electrons and the holes, both of them to move, both of them to conduct. So if you see, the first scenario is when BJT, that is bipolar junction transistor, will be in the cutoff region. Next one is when the BJT or bipolar junction transistor will be in the saturation region. So now let's start with the BJT in the cutoff region. When the BJT or bipolar junction transistor will be in the cutoff region, the input voltage will be equal to 0. Here if you see, what is my input voltage? Vin. So Vin value will be equal to 0. When the voltage value will be equal to 0, whether there will be any production of current? No. So what is the current flowing through it? Vin is coming through the base and moving. No. So IB, you can conclude IB will be equal to 0. What is IB? IB is my input current. When input current will be equal to 0, my output current will be also equal to 0. So you can conclude that my output current IC will also be equal to 0. Now if you see, my input current is 0, my output current is 0 and my input voltage is 0. At this situation, when all the values will be equal to 0, my VBC, that is voltage across base collector and voltage across the base and emitter, will act in the reverse bias condition. Therefore, voltage across base collector and voltage across base emitter will act in the reverse bias condition. When both of them will act in the reverse bias condition, there will be the high voltage drop. High voltage drop. So where the high voltage drop will happen? At the output. So what is my output? My output is VCE. Since VBC and VBE are in the reverse bias condition, there will be high voltage drop across VCE. Here there will be high voltage drop. Due to this high voltage drop, at the output, that is VCE, the switch will be off. Switch will be off. So if you want to draw the circuit, so this is my resistance, that is at the collector, you can call it as RC. Next, here my switch will be open. My switch will be open. This is my output VCE and there will be no connection with the emitter, which will be grounded. Since it is open, there will be no flowing of current, so my switch will be off. So you can tell my circuit is open, so my switch is off. My circuit is open, so my switch is off when it is in the, when BJT will be in the cutoff region. So it's vice versa, that is when BJT will be in the saturation region. So this is the resistance at the collector and this is the output VCE, and here if you see, there will be the closed switch. So there is the connection to the emitter which is grounded and there is no open space, that is the switch or the circuit is closed. When the circuit is closed, the current can pass through it and my switch will be on. So my switch will be on. My switch will be on, my switch will be on and my circuit will be closed. Vice versa you must write. When the bipolar junction transistor will be in the saturation region, my input voltage will be equal to positive values. Positive values, that is greater than 1. So my Vin value, which is the input voltage value, will be positive value. Since it is positive value, IB, that is my input current, will increase. When my input current will increase, my output current IC will also increase. When both my input current, my output current will increase, with the input voltage being positive, then my voltage across base collector and voltage across base emitter will act in the forward bias condition. Therefore, VBC and VBE will act in the forward bias condition. Since these two voltages are acting in the forward bias condition, there will be the decrease in the voltage drop. So voltage drop decreases where? At VCE. That is at the output, the voltage will drop. So less voltage drop will happen at the VCE. When less voltage drop will happen at the output voltage, you can conclude that my bipolar junction transistor, which will be in the saturation region, is on and its circuit is closed. Then only the current will flow through it and my switch will be on. So hope you understood the concept, how the transistor will act as a switch. If you have any doubt regarding this topic, please do comment below. I will clarify it. If you liked the video, please subscribe and support us. Thank you.